Today we are exploring an exciting topic: how slag, an industrial byproduct, is transforming noise control and sound absorption technologies. This is not just about recycling, it's about revolutionizing how we design for silence. Let's begin by understanding the basics. Slag is the byproduct of metal smelting and refining, often from steel, copper, or iron. It's rich in silicates and oxides, and surprisingly, its unique physical structure makes it a hidden gem for acoustic engineering. Now, how does slag help with sound? Its porous nature traps sound waves, converting that energy into heat through friction. Compared to conventional material like fiberglass or foam, slag performs similarly but with extra durability and environmental benefit. Application of slag in acoustic field has a tremendous role. Like slag's acoustic versatility is very impressive. From walls and floors in building to noise barriers along highway and industrial enclosures, it's already making quite waves. Even decorative panels can benefit from its sound absorbing property. Coming to the properties of slag for acoustic application. Now question arises that why does slag excel here? Its combination of high density and porosity disrupt sound waves very effectively. Plus, it's a thermally stable, perfect for high temperature environments. It's also eco-friendly and budget conscious, making it a top contender for sustainable acoustics. Now, coming to a comparison which will sensitize us, and this is about a slag versus other material. Let's compare. Fiberglass is great for absorption but weak in blocking. Concrete block noise but doesn't absorb well. But if we think slag, which is on the last row, it has a both activity surprisingly well. It does both. Its dual action is what makes it superior in diverse acoustic contexts. Now let us see few case studies and research finding. The case studies validate slag's potential. In Europe, highway use steel slag for noise barriers. Blast furnace slag enhances acoustic concrete. Research reveals 70 to 80% sound absorption in mid frequency ranges, ideal for traffic and industrial noise. Now, coming to the shocking global data, the scale and the performance of slag globally: 250 to 300 million tons of slag were produced yearly, yet less than 35% is utilized, which is a very sensitive data, and it grow a lot of concern. Every ton used in acoustic prevent 1.2 ton of CO2 emission and saves significant landfill space. With hemp reinforced slag, absorption can peak at alpha value, which is equivalent to which is equal to rather 0.99, outperforming traditional material. Here is a snapshot comparison. Slag composite outperform mineral wool and polyurethane in absorption, fire resistance, and carbon footprint. Plus, they are more cost effective also. It's a win-win for sustainability and performance. India faces an acoustic crisis, rupees 12,500 crore in annual health losses due to noise. Metallurgical plants impact worker hearing, yet we produce over 150 million tons of AF slag, enough to build 7,500 km of noise barrier. We must pivot towards high value acoustic application, and it is also must for us in days to come. Solutions are emerging. Geopolymer slag foams reduce noise and improve insulation. Slag lime hemp panels cut building cost. In a steel plant, closed pore slag ceramics reduce machinery noise by over 11 decibel. Highway projects using slag show higher absorption and better drainage. A double advantage we can say. So from 3D printed metamaterial to slag-based panel in steel plants, innovation are rapidly evolving. These applications target previously unblockable low frequency harms and bring industrial noise level down dramatically. In conclusion, slag is not just waste, it's a solution, a sustainable, high performance acoustic material that fits into a circular economy. With more research and strategic adoption, we can turn today's byproduct into tomorrow's innovation.